Today we are going to discuss river problem. In river problems, you'll find that it is basically an application of addition of vectors. So it is the velocity addition there. Here we'll discuss the different cases like what is the time of swimming, time of crossing, what is the direction in which the swimmer should swim to cross a river in shortest time, what is the direction for the shortest path, and what are the different cases if suppose the speed of the river is more than that of the swimmer, will he be able to cross the river, and if so, what is the direction for his shortest path. So all these cases we'll discuss in today's discussion. So let's start the river problems. Here, let's first of all assume that we have a river and it has its width, which we represent it as small t. This is the width of the river, and the river is flowing with a speed, say u. So u is the speed of the river flow. Suppose here we have a swimmer who is swimming with the speed v at an angle theta with the direction of the river. So this is the point from where he is starting. If you just mark this point as A, which is the point on the opposite bank. Now, if we consider here, river speed is u, swimmer speed is v, and swimmer is swimming at an angle theta with the direction of the river flow. So his actual path will be something which is given by the resultant of the u and v velocities. So if you complete the parallelogram and show it, it will be going, and suppose it is meeting somewhere at this point. This is suppose x. So that means this is the point basically where he will strike or where he will reach. And now suppose we assume that his actual speed is due to this one is suppose w. W we are assuming as the effective speed of the swimmer. So here, first of all, let's see that if v is the velocity of the swimmer, here we are, what we are using? We are using u as the river flow speed. V is speed of swimmer in still water, and W we are assuming as the effective speed of swimmer. And let's suppose that the d is the width of the river. So first of all, what we can do, we can resolve this v along and perpendicular to the direction of river flow. So if you resolve this, in that case you will get component in the perpendicular direction as v sine theta, and along the river flow it will be your v cos theta. So component of swimmer speed in perpendicular direction to river flow. This is what? This is your v sine theta. Remember, we have resolved the velocity of this swimmer in two directions. One along the river flow and other perpendicular to the river flow. This v sine theta component, which is perpendicular to the direction of the river flow, will be one which is responsible for his crossing of river. So v sine theta will decide what will be the time taken by the swimmer to cross the river. Whereas the v cos theta, this one will get added with the speed of the river. And in fact, Due to that, he will be moving in the direction of the river flow. So he will get carried away with the direction of the river flow through some distance, and suppose he is striking somewhere at point X, that is called as a drift, where he is finally striking there. So this V cos theta will be that particular component which will be responsible for the drift, along with the speed of the river flow. So now if I take the time of crossing the river. Now for this, width is d and the component is your V sin theta. So this will be the time of crossing. So t will be equals to d by V sin theta. This is the time of crossing for the swimmer for this particular case. Now suppose we want that what is the minimum time to cross the river. So minimum time of crossing. Now to find that, what basically you have to do, you want to find t minimum, which is basically the minimum value of this t. We want this minimum value of the t there. So this is your d by V sin theta. So this one's minimum value we have to take. What will be its minimum value? This is your d by V. And this is possible when sin theta is equals to 1. Because to have the minimum value, the variable term, here in this particular case for a given d and v, it is the theta term which is the variable one. So if sin theta will have the maximum value, then this fraction will have the minimum value. So in that case, sin theta should be 1 or theta should be pi by 2. That means if the swimmer wants to cross the river in minimum time or in shortest time, in that case, he should swim in perpendicular direction because theta we have got it as 90. So he should swim there in perpendicular direction to the river. This is the direction of his swim. But remember that in this case, although he is swimming in the perpendicular direction, he will be taking minimum time there to cross the river. But he will not be able to reach this opposite bank at the exactly opposite point. Because there will be resultant of these two, V and U. So his speed will be somewhere in this direction and he will be striking somewhere here. So there will be some drift. So in this case, time taken is definitely minimum, but there will be some drift there. So this T minimum, we have got that this is equals to T by V. And for that, we should swim in perpendicular direction to the river flow. So if in anywhere or in any problem, if it is asked, what is the direction for the shortest time? So the direction will be giving you that the theta should be 90 degree or it should swim in perpendicular direction to the river flow. Now, if you take what is his effective speed in the direction of river flow. So effective speed of swimmer in the direction of river flow. This one will be U, which is the speed of the river flow. So this is still there because it will add with the component of the swimmer speed in this direction. So U plus this V cos theta. This is his effective speed. And if you want to find what is the drift, that means what is this particular value? This is your drift. That means the distance where exactly he will be striking from the opposite point on the other bank. That means this is the A is the opposite point from where he is starting on the other bank. So the distance where actually he is striking, that is, he is striking suppose at the point X. So this particular distance between A and X, that will be called as the drift. So this drift will be equals to effective speed multiplied by time of crossing. So here what we have taken, this effective speed we have got u plus v cos theta, and time of crossing was your d by v sin theta. So in this case, drift will be equals to this value, u plus v cos theta into d by v sin theta. This is the drift. Now here, you may be asked to find what is the minimum drift, or in which direction he should swim so that the drift is minimum. So for that, we get different conditions there, or different cases we get. For minimum drift, if you consider, you had what? U plus v cos theta into d by v sin theta. And if you take the minimum value of this drift, we can take this one as 0. That means you will be striking at the point A. So if you use this one, what you will get, u plus v cos theta term should be 0. And if this is 0, then cos theta is equals to minus u by v, or theta will be equals to cos inverse u by v. That means this will give you the direction in which you should swim so that there is minimum drift. And remember, for that minimum drift, the condition is that cos theta is minus u by v. And here, if you get the suppose cos theta as minus, so cos theta value, if it is minus, that means it will be lying in the second quadrant there, or the angle will be obtuse. Of course, it may be there in the second as well as in the third quadrant. But if you consider the swimmer's condition case there, if he is striking from this particular point, and if this is suppose v, that is the swimmer's velocity direction there, and river speed is u, so the resultant of the two will be this one. And this is the point from where he is started, and he is reaching the point A, because his effective speed will be there in the direction O to A, but basically he is swimming in the direction this, from point O to say point P. So in this direction he is swimming at an angle theta with the direction of the river flow, because river flow we have taken as this direction, that is from left to right, and u is its speed. So if the angle is obtuse, in that case you will get cos theta as minus u by v. So that particular value will give you what should be the angle at which he should swim. So here he will be reaching at this point, and in this case, it will be the drift will be equals to, drift is 0 in this particular case. But remember, this is there for u less than v. That means when the swimmer speed is more than the river flow speed, then you will get this condition. That means cos theta will be your minus u by v. And in that particular case, the drift will be equals to d. Suppose I want to know what is the length of the path. Length of the path means this is suppose basically his effective speed or actual speed there in general. This will be the length of the path described. Here it will be this particular length, which is the actual direction of his swim. with respect to the river. So in that particular case, this is the direction in which he will be ultimately swimming, and this will be the length of his path. So length of the path will be equal to length of the path L will be equals to T. That is the width of the river, because it will be equal to the width of the river. So this is what you will get, and all these you will be getting when U is less than V. Only in this condition you get. Most of the problems which you will come across will be given where the speed of the swimmer is more than the speed of the river. So there you can easily apply this condition there, and you can find out in which direction he should swim so that to cross the river in shortest path. This is also called as the shortest path. Whereas, if suppose you get any particular case where the river speed is suppose more than the swimmer speed, then what will happen? If V is less than U. So in this particular case, that means now we are taking the speed of the river flow is more than that of the speed of the swimmer. So in this case, what will happen? For shortest path, again, for shortest path, this cos theta, this time it will be equal to V by U. So here, in this case, remember, for shortest path, you have two formulas. One is your cos theta minus V by U when V is less than U. And you have cos theta equals to minus U by V when U is less than V. Now, what happens here in this particular case? Suppose we have taken this as the river. Swimmer is swimming in this direction. Okay. And here, this is your V. So here, if we want that he should reach at this particular point, this is the direction of the river flow. And now, if you want that he should reach from point O to point A, then this will be basically a right angle triangle. If it is a right angle triangle, in that case, the swimmer speed, which is V, now it is coming in this particular part. That means it is something like the hypotenuse there. G will be in this direction, and its length will be more than these two portions. So here, if this is the case, that means he wants to reach the opposite bank at the exactly opposite point, then V should be greater than U. But here what is given? Here it is given that V is less than U. If this is V and U has to be more than this, that means this one will be U there. And if this is U, in that case, this will be his actual path in which he will be swimming. So that means he will not be able to reach this particular point A, but he will strike somewhere here. So for this case, when V is equals to, or V is less than U, he will never be able to reach exactly opposite point on the other bank. That does not mean he will not be able to cross the river. He will definitely be able to cross the river. But only thing is that he will not be able to reach this particular point A. Because just now we have discussed that it will be a right angle triangle if you are using V, U there and effective speed. In this case, if this is possible that he will be able to reach point A only if V is more than U. If it is not there, in that case, he will reach somewhere else there, say the point X. So for this particular case, minimum drift is not equal to G. Now, then what do you mean by the minimum drift there? With the given velocity V, swimmer can swim in different direction. Suppose he is swimming in this particular direction, he is reaching here. if he is swimming in this direction, this is suppose another angle. In that case, u will be this, that means he will be reaching somewhere. If he is swimming in this direction, then again u will be in this direction, he will be reaching there. So that means here x, x dash, x double dash, these are the points where he will actually be reaching there when he is striking at an angle, say theta 1, theta 2, theta 3, like that. Out of these, definitely one has the minimum value of the drift. So that means this is AX, which is the minimum out of all those drifts which is possible there. So that one will indicate the minimum drift there for that condition. So for that case, it is not equal to 0, but in that, definitely one of the paths will definitely be there where the drift has minimum. To take the length of the path L, in this particular case, it will be your d into u by v. This is your L. That means this is the length of the path. This time, this one will have a value which is d into u by v. If u is greater than v. So when this is greater than v, that is the river speed is more than swimmer speed, then this will be the length of the path. In the earlier case, what we have taken, when the swimmer speed was more than the river speed, in that case, he was able to reach the exactly opposite point. So there the drift value was 0. There the length of the path was equal to the width of the river. So this type of things will be there, and you will have to take care for all such cases there. First of all, you will have to see whether the river speed is more or swimmer speed is more. Accordingly, for minimum drift, what should be the angle, direction in which he should swim. So cos theta is either minus u by v or cos theta is minus v by v, depending upon whether u is greater than v or v is greater than v. To remember this, you just remember one thing, that cos theta has to be a negative quantity first for minimum drift. So it may be your u by v, or it may be cos theta equals to minus v by u. Sometimes if you get confused anywhere for that, you know that cos theta value has to range from +1 to -1. That means the numerator there will never be greater than denominator. Because if numerator is more, then the fraction will be more than 1 or more than -1. So in this case, it will be applicable when u is less than v. And here this will be applicable when v is less than u. So that way you can remember and you can easily get the answer there. So remember two things there. One type of question will be there where we ask what is the shortest path. And second is there, what is the shortest time? If it is the shortest time, he should swim in perpendicular direction. In that case, definitely he will not be able to reach the exactly opposite point from where he is starting. But he will definitely be able to cross the river in shortest time. If it is the shortest path, in that case, the drift value will have the minimum value there. It may be 0 or it may have some value there, depending upon whether the river speed is more than swimmer speed or swimmer speed is more than river speed. Normally, you will come across the cases where you will have the river speed less than swimmer speed. In most of the books, you will find like that. But in other cases there, you may be getting the problem there or numericals there where the river speed will be more than swimmer speed. So in that case, don't forget that you have to use the formula for minimum drift, cos theta equals to minus u by v if u is less than v, instead of cos theta equals to minus v by u. So all these things are there in the river problem there. Suppose it is given that if T1 is the time taken to cross a river with still water and T2 is time taken in flowing water. When swimmer is striking perpendicular direction to the river flow, then T1 is less than T2 or T1 is more than T2 or T1 is equal to T2. It is given there that suppose we assume that we have a river of a particular width is there. Suppose I assume that the width is D. In first case, it is the still water. Okay. It is just like a lake you can imagine. And the swimmer is swimming so that to cross this particular river, and he is suppose swimming with a particular speed. So with the still water, if he is swimming, it is taking time, or he is taking time T1. So what will be this particular time T1? It is equals to D by V. Second case is there when the river is flowing with a particular speed. Suppose I assume that the river is flowing with the speed U and he is still trying to cross the river there. It is asked that now time taken to cross the river is T2. So what is the relation between T1 and T2? Here, many times we get confused that if swimmer speed is there and river is also there, he will have some different velocity there. Definitely will have some different velocity, which is given by root over v square plus u square there. But time taken to cross the river, if you have to find, it is basically he is striking in perpendicular direction. So in this case, the time taken to cross the river will, if you take as T2, it will still will be d by v, because d is the width and v is the velocity with which he is trying to cross the river. So he is striking in perpendicular direction there, whether it is still water or it is flowing water. So in that case, it will be same. So T1 will be equals to T2. So this option is the correct one. Next question. A man can swim with a speed of 4 km per hour in still water. How long does he take to cross a river 1 km wide if the river is flowing at 3 km per hour and he takes his strokes normal to the river flow? How far does he go when he reaches the other bank? So here, this is suppose we are representing as the river and its width is given that it is 1 kilometer. So 1 kilometer is the width. And the man can swim at 4 km per hour. That means V is given as 4 km per hour. And the river speed is given as 3 km per hour. It is given that he is striking normal to the river flow. That means basically he is trying to swim in this direction. So he is in this direction. And due to the river flow, he will be carried away and his actual speed will be given in this particular direction. This will be U and this will be the W here. But here, first of all, you have to find what is the time taken to cross the river. So time taken to cross, T will be equals to the width D divided by the speed, because he is swimming in the perpendicular direction there. So it is your D by V. So it is your 1 by 4 hours. That is, it is 15 minutes. Second is, how far does he go when he reaches the other bank? That means it is asked about the drift. So that drift will be equals to the time taken. This is your 15 minutes or 1/4 hour. And what is this speed? Because he will be carried away along with the river flow. Now this is only due to the speed of the river, because he is striking perpendicular direction. So any component of his velocity in the direction of the river flow is not there. So in that case, it is only U into the time taken. That is the time taken, which is your 3 into 1 by 4 or 3 by 4 kilometer. That is your 750 meters. So this will be the answer. Let's take another question. A swimmer wishes to cross a 500-meter wide river flowing at 5 km per hour. His speed with respect to water is 3 km per hour. If he heads in a direction making an angle theta with the river flow, find the time taken to cross the river. And second part, what is the shortest possible time of crossing? This is exactly based on the formula which we have discussed earlier. That means here we have the river, and suppose the river speed is u, and he is swimming there at an angle theta with the direction of the river flow. And we assume that the width is supposed to be. So in this case, the component of the velocity which you take here, this is your v sine theta. This is the component in the perpendicular direction to the river flow, because that one will help it to cross the river there. So if in the first part it is asked find the time taken to cross the river, so the time taken to cross the river t, this will be equals to d by v sine theta. And now what is d there? It is given as your 500 meter, and speed is given as 3 km per hour. So let's convert that 500 meter into kilometer. It is half, and then it is your 1 by 3 sine theta. That means it is your 1 by 6 sine theta. This is the time taken. And in the second part, if it is asked what is the shortest possible time of crossing, so the t minimum will be equals to the minimum value of this time. So this will be your 1 by 6 into sine theta minimum value, and that is your 1 by 6. So it is 1 by 6 hours. Of course, it will be there when sine theta is 1 or theta is pi by 2. That is the additional information that we can give, but basically it is just asked what is the time taken or shortest time taken. It is 1 by 6 hours or it is your 10 minutes. So here also it is this much, or you can take it as 10 by sine theta minutes. Next problem, it is just a continuation of the same problem. So in the above problem, if he has to reach the other side at the point directly opposite to the starting point, if he reaches somewhere else, he has to walk down to this point. What is the minimum distance he has to walk? Now here, see, the problem is given where the river speed is 5 km per hour. And his speed, that is the swimmer's speed, is 3 km per hour. So in this case, if you consider, he wants to reach the opposite bank at the point directly opposite. So obviously, as u here is greater than v, he will never be able to reach there. So first part is there. So that means the drift value will not be reached. He will have to move through some distance because he will be ultimately reaching somewhere else there. And he will have to walk down from that point. So we have to find what is the minimum distance that he has to walk. That means indirectly it is indicating that it is a question of minimum drift there. And again, as with the given data there, swimmer speed is less than the river speed. So obviously the minimum drift will not be 0. So for minimum drift, what we will put? Cos theta equals to minus, drift formula will be equals to u plus v cos theta multiplied by the time of crossing. So time of crossing will be your d by v sine theta. So this value we have to substitute. So let's substitute these values there. So here u value is given as 5, v it is given as 3. So it is your 3. And now cos theta value is your minus v by u. So it will be equals to minus v. That means it is 3 by 5. And d, this is your 500 meter width was there. So as it is your 500 meter, so that means it is your half kilometer. into 1 by V. V is your 5, V is 3, and now it is sine theta. So this can be written as your 1 minus cos square theta. So this is equals to, this is your 25 minus 9 by 5 into 1 by 6, and it's put this value. It is your cos square theta. Cos theta value is how much? Cos theta value we are getting as minus V by U. That means it is your 3 by 5. So this is your square root of 1 minus 3 by 5 whole square. So this is your 16 by 5 into 1 by 6, and now it is your root over, this is again 25 by minus 9 by 25, that means it is again your 5 by root over 16. So this is your 16 by 5 into 1 by 6 into 5 by 4. So this 4 will get cancelled. This is your 4, 5 will get cancelled, and this is your 2 by 3. So this is your 2 kilometer. That is, this is the minimum distance he has to walk. So that will be equals to 2 by 3 kilometer.